So, based in Sweden, Sweden is a part of Europe. I will start off by talking a little bit about the focus we have in Europe right now. And what is driving the development of vehicles, both trailers and tractors. It's not that fun, it has to do with greenhouse gases, emissions. We have targets. We have the first target upcoming in 2020. We're supposed to reduce the emissions by 20% of the 1990s levels. We already achieved that. So, but as you see, the trend is not that good. We have stagnated. And we have new targets upcoming in 2030 and 2050. And all projections right now shows that are pointing at we're going to miss these targets. So we need to do something. Commercial Vehicle Forum, transport industry. Splitting the previous slide into segments. How are the segments doing, the sectors? Well, basically all of the sectors have reduced their greenhouse gas emissions, except one, the transport sector. It's looking better, but we have actually increased the amount of greenhouse gas emissions by 20% since 1990s. And this is Europe figures. This leads to this slide. I and we believe that the transport industry is changing. The focus is nowadays on making things leaner and trying to make it a lot cleaner. So reducing the carbon footprint. But with leaner, I mean using less resources. It could be steel, could be fuel, but also making them more efficient, so carry more load on each vehicle. Steel is a part of the solution. We're using a lot of steel today, and I'm going to highlight 3 points here why we believe steel is such a good material to use. First of all, it's highly versatile. You can weld it, you can form it, you can shape it, you can do basically a lot of different things with it. But most of all, it has a very competitive strength to cost ratio if you compare it to, for example, aluminum, carbon fiber, or any other material. Steel is really cheap per strength unit. Number two, it's 100% recyclable over and over and over and over again, forever. And high strength steel. We can actually upgrade the steel today, so we can use less steel to do the same job as we did yesterday. A little bit about what we're facing. Showing our vehicle, and we have basically 4 forces trying to retard our vehicle. One of them is aerodynamics, but then we have 3 more. For example, mass determinants. So they're a function of the mass. So if we should have a vehicle that has good fuel efficiency, for example, we would like to have low mass. And that is of course when we have a vehicle that is unloaded. But if we have low mass, we can also have more payload on it. The panel discussion before the break, we were talking about changes in norms. It's good and all because we get cleaner engines, but as said, it will add weight. We also have research showing that the more, sorry for the kind of bad picture, but it's a trend that is important. Horizontal axis, payload. Vertical axis, it's fuel efficiency. So you have a strong correlation between the payload and fuel efficiency. If you have more payload, your vehicle will be more efficient. So we need to reduce mass of the vehicles. Can high-strength steel help? I will show a couple of cases where our customer have used high-strength steel and good weight. First is a company out of Italy called Mantella. These are the Swedish steel prize winners from the last steel prize. And they used 960 material to replace the main girders that was welded I-beams before. And they cold formed Z profiles as main girders instead out of 960 material. They also made a lot of work on the bucket, so the complete trailer was 30% lighter. They had, of course, a lower dead weight, but they also had significant production savings or cost savings in production when they reduced the welding and was cold forming instead, handling less material. When you upgrade and connecting that to what we talked about previously, greenhouse gas emissions, we have something called eco-upgraded in SSAB, and it's a way of quantifying how your upgrade will affect the CO2. You can see it as a marketing tool, but it's really good because it shows the benefit from an environmental point of view in really good matter. And it's 4 terms, actually, that we sum up. If we upgrade, we use less steel to do the same job, so we emit less CO2 in production. We can upgrade to have a longer service life, so the total CO2 cost of a lifetime is lower. Lower weight, as said, you're reducing the fuel when you're driving empty. But you can also have a higher capacity if you have a lower vehicle weight, so you can load more, and the total efficiency will be better. And just showing another example, a lot of data, but this is an upgrade example from Sweden. They upgraded 3 containers. Original design was 355 steel. They upgraded to a wear steel, Hardox 450, reducing the total weight of the 3 containers by 2,100 kilos. So quite a lot. They also had a lot of stiffeners on the outside before. They removed that one. What happens? Well, the drag, the aerodynamic forces get much better. So it's much leaner to drive. And 2 tons basically removed. They can increase the payload by 2 tons, but it's also 2 tons cheaper or lower weight to drive when you're unloaded. Just highlighting one. Over the lifetime of this, it's 12 years. They're saving roughly 30,000 liters of fuel. It's pretty good. And it's not, extremely hard to do. So if we're using less steel to do the same job, what do we face? During the last 10 years, speaking to a lot of customers all over the world, I think that all of the challenges that we meet, could be summed up in these 6 points. It could be tradition. You're used to use some kind of steel. So if we're going to use high-strength steel, what does it mean to us? Also connected to knowledge. How do we weld it? How do we form it? What do we need to think about? Using less steel to do the same job, usually you decrease thicknesses. What happens with the stiffness of our structures, vehicles? What happens with stability? Sometimes you can meet resistance from this point, norms and design regulations that is not validated for high-strength steel, but I would say nowadays it's more for 1100 and 1300 material. And then the last, fatigue. Using less material to do the same job, you will increase stresses in the structure. What is driving fatigue is stresses. So you need to think about that. But we've been doing this for quite a while, 30, 40 years. So we have a lot of knowledge on how to upgrade. So we have, as all our competitors, like a tech support that is taking everyday questions. But we also have the part that I belong to that we like to call innovation support, where we help the customers facing these challenges on the previous slide. Just to show fast a little bit how we can work. We're talking about regulations that change, and this is an example in Europe, we're talking about the rear underarm protection device that was mentioned in the panel discussion before. And in ECE countries, we will have new regulations from 1st of September this year, and we will have 2 years to implement it. So all the green countries will have new regulations. And why do we have new regulations? Well, they realized that there was an unacceptable level of fatalities from impacts from the rear on trucks and trailers. What we're actually saying is that we're fed up with this. We want this instead. So we need a stronger rear underarm protection device in order to